My most recent multi-tool CNC project was accomplished the old-fashioned way with manual tool changes and manual tool zero setting. And that set off the old, "can't we do this better?" mindstorm. That mindstorm led to a day and a half wasted trying to use toolsetter macros I found on YouTube and Google, all without success to auto-set the proper Z0 for the second tool. Then, after so much wasted effort, I stumbled over a FluidNC feature that would have taken care of the tool setting automatically in a link I didn't follow when I was looking for some other info, but remembered that something interesting was out there. The manual ATC feature of FluidNC is so easy to implement, I was beside myself for all the time wasted and completed the implementation in maybe 1/2 hour. It is implemented by adding this ATC reference line to the spindle definition. Then you add the new ATC manual definition with data specific to your CNC, such as appropriate seek and feed speeds or rates, the XYZ position where you want to do the tool change, and then ETS impulse with XY being the center point of where you have mounted your sensor, and Z as the match plunge. All of this can be referenced on the FluidNC wiki. One very important thing, this M61Q1 line designating that tool 1 is selected must be in your code unless your CAM software already includes a line with M6 to set tool 1 as the current tool. For me, I updated the job start text of ESSLCAM to make this happen. If this is only a one tool G-code job, it has no effect. From my experience, you also want to include a M61Q0 in the index, which I also updated in ESSLCAM. I'm still learning all of the consequences of this tool designation code, such as what happens with an aborted job. So I am adding a set tool 0 macro to the web UI. Only when an M6T2 tool change command is found will the automation magic happen. Here is how it works without creating dust for this demo. I have mounted my touch plate on the bed, isolated with double stick tape. The spindle is electrically connected, so I don't need to hook the clip up to the spindle. For the benefit of this demo, I have a test piece that I have zeroed a 3/8 inch dowel on that I can retract as tool number 2. I will activate the code that has the tool change in it. The ATC manual function will now determine the length of tool 1. In its configuration, you set its location and these feed speeds used to probe the tool change. Now it's moving to the tool change position, and I will retract the dowel as tool 2 and then continue the job. You also set the tool change position. Now I will continue, and it will probe the length of tool 2 and proceed with the job. When the job continues, tool 2 should begin to cut 1 millimeter below the top surface of the workpiece, which I will slide into position to demonstrate. One millimeter. P.S. When the job ends or aborts, the Z0 reverts to its position with tool 1. I hope this helped your efforts or solidifies your interest in FluidNC. Let me just say that right now I have zero regrets with the switch from Mach 3 to FluidNC, and I am now a supporter of the project. Thanks for watching.